impact hammer. And there was a picture in, let's see, in Jim's presentation that showed that hammer, and I'm sure a lot of people are familiar with the PCB impact hammer. I was on their website today and noticed that the price of the hammer has actually gone up recently. So for that PCB hammer, it's about $900. Then you also need the signal conditioner to go along with it. And so that is an expensive piece of test equipment for the average workshop, definitely. So we've had the idea to maybe refine the hammer design a little bit and make a cost-effective version. So I want to share with you just where I'm at on that, starting with the proof of concept hammer. And so the first question really is it possible to make a hammer, and can we maybe meet some of the specifications for the PCB hammer? And just to give you a few numbers, the PCB head mass is about 1.36 grams for just the effective mass of the hammer head. And this first, let's see, actually the second prototype had a final hammerhead mass of 1.163 grams. So it is a little lighter than the PCB hammer, and there's actually room to make it even lighter, given a few advancements that Joseph has worked on for the handle design. So this is the first prototype, and it's really just an aluminum block machine to house a piezo element, and this has a nylon tip on it. And so not sure how well you can see the oscilloscope here, but I'm just going to demo it on this violin. And so this first question, you can see the voltage on the oscilloscope. The first question is it possible to make such a hammer? And it looks like it is. And so the second prototype is a little more refined machine from rod stock. It has just an aluminum tip on it, a shorter handle. And here's, it's on channel 2, so it'll be a blue voltage spike. And so that's where the design stands right now. This hammer is the hammerhead that weighed 1.163 grams. And it has an aluminum handle with the coax wire running through it. And there's a design improvement that can be made to actually remove more material from this hammerhead and make it even lighter if that's desired. And I had a conversation on the other part of this project, which is the preamp design. And Indiana University in South Bend is working on the preamp design. That's the acoustics lab that I used to work in. And so they're designing a 2-channel preamp for the hammer. And so it's a package of the hammer and the preamp, and it will be built into the existing measurement rig, and potentially replacing the PCB hammer if all goes well. And still the early days of prototyping, but seems to be viable. And really that's about it. If there are any questions on anything.
Well, that's cool, because as you point out, the actual commercial unit is quite expensive. So are there any questions? If you have questions, please use the raise hand function. Christopher Dungy.
Hi, Tom. Thanks. Thanks for your prototyping work. So what kind of cost are you talking about comparable to the PCB hammer?
So for the preamp in the hammer, the goal is to have it below $300. And as it is right now, that is doable.
And is this something that you're going to make available, or are you just giving us resources that we would then have to assemble the parts ourselves?
It'd be
something we get it from you.
Yeah, I'm planning on making hammers for whoever wants one if it all goes well. That's the goal.
So will you let us know when you're taking orders?
Yeah, I'd say tentatively it would be, by the early summer, but there's a few more tests that I have to do on these hammers, and we're going to refine this final design within the coming weeks, and there'll be a lot of tests to do, but I would say by summer we could start having
And
that
then,
conversation.
and then will it be able to plug into a computer USB? Is that?
Yeah, it'll go from the preamp and it'll plug into a converter box like the Rowell or a Focusrite converter box that is, I think, currently used for getting the signal into the software.
Okay.
So it's designed to use standard sound cards, in other words.
Yeah.
Yeah. Mm-hmm. Any other questions, Chris? All right, then. Mark Rowell.
Hi, Tom.
Hey.
Thanks for showing the hammer. I'm wondering what piezo or tip you're using, like what the actual element is.
It's a piezo that's about 1/8 of an inch in diameter and also about 3.2 millimeter by about 2 millimeter. And it's a piezo ceramic element.
Is it one of the Thorlab ones or?
It's APC piezo element.
I've also been building some small hammers. I've been 3D printing them, and I've got like the Thorlabs. Like it's a piezo stack, and yeah, it's about $30 for the cost. Like the sensor is $30, and then the PLA is like a couple cents.
Very cool.
So yeah, it's cool to see. I mean, yours are much nicer with the aluminum. But thanks.
Okay, so Gary Scavone texted a question. What about different tip materials? Was his question. But I have a question for Gary, which is, why would you want different tip materials? What are you trying to accomplish there?
Can you hear me?
Yes, go ahead.
Okay. I mean, normally I use, on the PCB one, I use the metal tip because we want to get the highest bandwidth. But, if you're working on some system with light wood characteristics and you might not want to dent it or something like that, you might want to switch to a plastic tip or something like that. So
right now I've experimented with the nylon tips, and I know the PCB has a titanium tip without any covering. The current design has an aluminum tip, and aluminum is relatively soft, and the weight of the hammer is light. I understand the concern with putting Mars and dents into violins, and so we'll definitely be experimenting with even a thin layer of something rubbery or dip the hammerhead or something like that. But I believe Joseph has experience.
Yeah, I'll be talking about hammer tips, so we can continue it there.
Okay.
I'm using a plexiglass tip, and so it's very hard and it's very flat, so it's not indenting like the by default metallic tip from the PCB hammer. And so I can get the very high frequencies without having any problem of indenting the bridge. And it was just like a plexiglass. No, how do you say that in English? So plexiglass, I think another.
Plexiglass is good.
Plexiglass, yeah.
Yeah.
is that something, because George Bissinger used to have something, it wasn't plexiglass though. Is that, so you stick it over the tip? Is that what you use, Claudia?
Yes, I stick it over the tip, and now we calibrated the hammer to take into account this cap that I put on. I found it very, very useful. Because it's easier to get rid of the double hit because it's very flat, and I don't have any problem with indenting the bridge that I could have had with the metallic tip.
Okay, any other questions? All right, thank you very much, Tom. And